Hello, welcome back to MOT Economics YouTube channel. How are you? Some of you may be seeing this video as one of our videos for the very first time and be wondering what is the measure of dispersion doing inside of economics, right? So the thing is that data is important in every field of study actually right now. And then there's a field in economics that is called econometrics, and econometrics is just the application of statistical tools, mathematical tools, right, to economic theory in order to verify um, if economic theory are if economic theories are saying the truth or if they are not enough to explain a particular phenomena. So yeah, we've looked at the concept of measure of central tendencies, otherwise known as measure of positions or locations. So in today's lesson, we are going to start with the measure of dispersion. So what exactly is dispersion? So it's there. Dispersion operation refers to the degree at which a numerical data tends to spread about an average value, right? It is the degree at which a numerical data tends to spread about an average value. So it could be called the measure of dispersion, it could be called measure of variation, it could be called the measure of spread. So it's just looking at, okay, this is an average value, it could be a mean, it could be mean usually. This is the mean. So how far or close are other observations from that mean, right? So how far is another observation from that mean, or how close is another observation from that mean? So if the mean age were 13 years, right? So what are the other ages and how close are they to the mean? So let's say there's an age that is 15 years, so not that far away from the mean, but if you have 21 years old, then that's kind of far away from the mean compared to 15 years old and on and on. So it's just looking at there's an average value, so how close or far away is a given set of observation away from that average value. Now, so we then move to the types of measure of dispersion. So the first and the easiest one is a range. And range is the difference between the smallest number in a data set and the highest number. Then we move on, we have the mean deviation, we have the semi-interquartile range. So it is still a range. Then we have 10 to 98th percentile range. You have the standard deviation and whatever else that I may eventually get to know in the future. So let's start. Um, you know, you may be wondering that what exactly is the new thing that you're going to learn from this lesson. But you know that the way we make our videos, in one way or the other, there's always going to be something new to learn. So let's dive straight into it. So I've defined range for you, right? So if you have this set of data, the first one, so this is just talking about the um, amount of money made by two set of students, right, from a weekend um, job, right, from working during the weekend. So the amount is in dollars. So for group A, um, some people made $12, some made $6, $7, $3, $15, and I think 18. Where is it? 12, 6, 7, 3, 15, 10, $18, and then $5. 1, 2, 3, 4, 5, 6, 7, 8. Now you have a second group, a group B, right? 3, 8, 8, 8, comma, 9, 9, 9, comma, and then 18. Now I want to look at some of the shortcomings of the range, right? Why the range is not a reliable measure of the measure of dispersion or of a measure of dispersion. Why it's not, a reliable measure. Why shouldn't just look at the range and then make informed decisions based on the range that you've calculated. Now, if you recall that when we're looking at the concept of mean, so we mentioned the fact that mean could also be limited in the sense that it is affected by extreme values, otherwise known as outliers. So you need to eliminate outliers from your data sets for your mean to kind of be reflective of to be representative of like the particular sample, or to be representative of a given um, an overall set of a given set of a data representative of it. So looking at this, we can rearrange to just make things kind of clear. It's not necessary to rearrange, but then we can just decide to rearrange all of these figures. So when we do that, we are going to have three. For the first one, we are going to have 3, 5, 6, 7, um, 3, 5, 6, 7, and 10, 12, 15, 18, 10, 12, 15, and 18. So we're arranging that. Then for group B, it's already rearranged. So 3, 8, 8, 8, 9, 9, 9, and 18. So what is the range for both? Now the range right, equals the highest number here is 18, the lowest number is 3. So 18 minus 3, which is 15. And if you look at this, highest number here is 8, lowest number 2 is 3. So the range here is also 15. So looking at this is telling us that both of them have similar range, right? And telling us that okay, these data sets, are kind of distributed. They have these data sets have the same measure of variation if you're using range as a measure of dispersion or as a measure of variation. But then, is it true that the range here is 15? Like in this case, $15. Like, is that exactly true? Like, is that the only thing that we should be looking out for? You just take these two things, and you're like, okay, so let's calculate the mean for both of them. So for the first group, when you add up 3 plus 5 plus 6 plus whatever, they are going to get 76. So we have 76 divided by 8. And then for the second group, this is for group A. And then for group B, we are going to be having 72, I think, divided by 8. So when we do 76 divided by 8 here, we're going to get a 9.5, so a mean of 9.5. And then here, we are going to get a mean of 9. So this is telling us that on average, right? Those in group A earned $0.5 more than those in group B on average. Those in group A earned $0.5 more than those in group B. So it doesn't necessarily mean that everyone in group A earned $0.5 more than everyone in group B. You've taken the average, right, which is what econometrics even eventually does. At the end of the day, just trying to estimate the mean value of the dependent variable based on repeated values of the dependent variable. You'll learn that in the future. All right. If you look at the first group, there are people that are not earning up to 9.5. This 1, 2, 3, 4 don't earn up to 9.5. So only the last four people earn up to 9.5. And then if you look at B, right, 1, 2, 3, 4, 5, 1 to 4 people don't earn up to 9, and then the other people, just three other people are barely earning $9, and then only one person here is actually earning more than dollars. So on average, right? So because this is a mean, okay. So on average, we have two means anyways. Those in the first group are earning $0.5 more, and those in the second group. Now, interestingly, when we look at when we look at group B, we said only one person is actually earning more than 9. Then there are so 4 different people are not earning up to 9. Then look at group A as well. You have a mean of 9.5, but 4 of the students there don't even earn up to 9.5, and this person that's earning 10 is barely earning more than 9.5. So if you look at it, about 4 people don't earn up to 9.5. So is this range giving us, is it representative of this data set? Like, is it telling us what it should be telling us? Because it's telling us that the measure of dispersion, if you're using range as a dispersion, right, that's the measure of spread, right, is just $15 for both of them, right? If we didn't even look at the minute, I've thought maybe that was all various given data set. So there is something that has to be paid attention to. Now, most of the people here, 6 of the people here, earn about $8 or $9, which makes sense. One of them is earning 3, one of them is earning 18. Those are extreme values because people just earn about $8, $9, right? So what we can do is we eliminate this an outlier here because it's really far from what others are earning, and then 18 too is like really far from what others are earning. So this is an outlier, right? So instead of brain telling us that they have the same variation, right? So let's look at what is true. So what we can do is we eliminate these outliers, 18 and 3, from both data sets, and then see if anyone has more variation, right, than the other value. So just eliminating the outliers. So if you eliminate the outliers from A, so I just call this, let me say, uh, okay, let me just call this I. Let me call this I. Okay, we are going to be left with 5, 6, 7, 10, 12, and 15. And then this other one, I call this A, I call this B. I'm going to be left with 8, 8, 8, 9, 9, 9. So the range now for both of them, the range, so 15 minus 5 equals 10, and then 9 minus 8 9 minus 8 equals 1. So now it is clear. After eliminating the outliers, it is clear that the first set of students' incomes have more variation than the second set of students' incomes. And it is obvious. I was like, how will you say your average was like 9.5 and some people are earning 3, 5, whatever. And this other person, his average is 9. And most of them are earning around that. So because both of them have the same variation, it's not correct. Right? So the only way it appeared like that was because of the two outliers that we had that was giving us a false representation of that particular data. So we can decide to calculate their new means. All right. So when we add up all of this, 5 plus 6 is 11, 11 plus 7 is 18, 28, 30, this 45, 11, 18, 28, 40, and then 55. 1, 2, 3, 4, 5, 6. So the mean, let me call this M. Okay, well, the mean, did you just get 55 over 6, right, for A, mean of A, right, then mean of B. So let me just call the mean of BII, mean of AII. Okay, so for the second one, we are going to be having the entire value was 72, and then we removed 18 and 3. So 72 minus, that will be 51. We have 51 divided by 6. So 55 divided by 6 is 9.1. So $9.1. And then this guy is $8.5. Alright, so looking at the total incomes of the first group, it is still more than the total incomes of the second group. So this is kind of the first situation, these guys were earning on average $0.5 more than the second group, and here $0.6 more than the second group. It's still fair, like it's still within reasonable values. But now we've eliminated the outliers, and then this is now showing us that clearly the incomes of students in the first group have more variation, like they are more different, right? They are more different than the incomes of students in the second group. Right. So more variation, more differences, 3, 5, 6, all of that, that pretty much different than the variation we have um in the second group. So yeah, that's about range. So one of the pitfalls of using range as a measure of dispersion is that it is also affected by extreme values, just like the mean. So it doesn't make it a very, very dependable measure. So don't just and because it uses lowest and highest values, the highest value may be an outlier, like a single outlier, and that is what we are using to talk about the rest. Like all you are trying to use to talk about the entire data set. So you are trying to use a flood value to talk about an entire data set. So what we do, like I mentioned, when we're talking about the mean, is for you to remove the outlier. So that's that. So once you look at how to calculate range if we are to be using a grouped data. When we are dealing with a group data, you don't know what the lowest number is exactly. Okay, you might know. Actually, we should know. No, we might not even know what the lowest number is exactly, right? And then what is more unlikely to be known is the highest number. And if you remember that in the lesson when we're looking at frequency distribution, and when we were teaching ourselves how to develop class intervals, remember from that example, right, that we have divided a particular data set in I think was it 7 places. I think we had a 0 to 9, a 10 to 19, um, yes, something like that. Then 20 to 29, on and on. I think we had about 8 of them or thereabout. So if you remember from that particular example, the last number in the last interval was not our highest number. Our highest number just happened to fall within that interval. So you can't be very sure, right, if the last number in the last interval is actually the highest number in a particular data set. So how do statisticians now measure range of a group data? So they use two approaches, right? They don't necessarily give the same answer or something close. Now, the first one is to subtract the highest class mark from the lowest class mark. So, using the class mark formula, so range, the first one, was the highest class mark. Okay, let me just call it highest x minus the lowest x. So I've calculated the class mass because we've been used to this data, chicken in kilograms, remember from the last lesson. So this is going to be 17.5 kg minus 1.5 kg. So that'll be 16 kg. All right. The second formula is to use a class boundary. So you use the highest class boundary minus the lowest class boundary. Now, I didn't say the class limit. So the highest class boundary minus the lowest class boundary. So range could also be highest class boundary minus the lowest class boundary. So what's the highest class boundary here? 19.5 minus 0.5, and this is equal to 20 kg. So any of them could be used. So I think the question should specify how to actually calculate the range, or if the question only I don't know, the question should kind of specify though. Now, what's the difference between the two, right? One is looking like it's going to be more accurate. Which one do you think is going to be? Exactly. That one that is not going to be like really affected by an outlier, right? Which is the one using the class mark, right? Because the one using the class mark is an average of the interval, unlike range when you're using the class boundary. So if the value here, for example, happens to be an outlier, and then that is still the value that you're using, you're adding 0.5 to get a class boundary, then minus whatever value that was here. Like the example we give, 3 was the lowest number. So let's say this was like a 3 to 6, right? A 7 to 9, on like that. And this was like maybe 16 to 18 or something. So, and then we are using 18.5 minus. Do you get what I'm trying to say? So, the outlier problem is still going to be there. So, using the class mark helps us to like reduce, not eliminate, but at least like reduce the problems of having outlier in the final calculation of our range. So these are the two ways that we can calculate range um, of a group data set. If it's on group data, I just find the highest number, subtract the lowest number from it, and that's that about range. So once we start talking about the mean deviation is also a measure of dispersion, and the formula for mean deviation, MD, equals the summation of f x minus bar x over summation of f. So which means that for our data set, we need to get f x minus bar x. It's a pretty simple thing. But after this, because you must have learned this in mathematics in secondary school, then there's something more important that we are going to learn afresh this particular lesson. So I just want you guys to like keep listening. So yeah, mean division of a group data. So looking at this particular question, then determine the mean deviation. Then B, determine the percentage of the students, because it's talking about student height. Determine the percentage of the student height that fall within the mean plus or minus one mean deviation. Then so the mean plus or minus two mean deviation. Then the third one, the mean plus or minus the three mean deviation. So I think that is actually where the real question is. Anyways, let's try to use this formula to first get our mean deviation. So our mean deviation for this question is going to be sum of fx minus bar x. So let's even try to get our x. So our x is going to be the midpoint 60 plus 62, 122 divided by 2. That should be 61. We have 61. Okay. Then 60, 61, 62. That is 3. I'll just be adding 3, 3, 3, 3, 3. Now we get the remaining answer. 61. This plus this is 128 divided by 2, that's 64. 64. Just keep adding 3 to the whole thing since they have the equal intervals. 61, 64, this will be 67. This will be 70. This will be 73. Okay. Then the next thing, we need x minus bar x. So we need the deviation. The reason why I have this slanted line is that you need the absolute deviation. That's the meaning of this slanted line. So absolute deviation is saying that your answers must not have a minus, just positive values. Okay. So let's first do x minus bar x. So yeah, x minus bar x. So, but we've not even gotten our x. Bar x is the mean. So we can just do some of our frequencies. Everything is 100. Then we've not even done fx for us to be able to get our mean. Let's get our fx out. Let me use it right so I can manage the space. So this time this is about 305. Okay, 64 times 18. How on earth did I not even calculate this thing here? 64 times 18. I don't even know all of these values now. So anyways, fill in the gap, sum everything up, and at the end of the day, our bar x in this question is going to be equal to 67.45. So what we are going to get here apparently is 6745. That's what we are going to get here. So just do your f of x, finish everything, add them up, you get 6745. By x, we've been doing it since sum of fx over sum of f. Sum of f is 100. So we just continue. Then this is 67.45. So with that understanding, then we can go and solve for x minus bar x. So the first one is in brackets. So x minus bar x, 61 minus 67.45. That's going to be minus 6.45 minus 6.45. Then 64 minus 67.45. That's going to be minus 3.45. On and on and on and on and on. So we can just fill the whole thing up. This is 67 minus this, so 0.45. Should be 2.55. It should be 5.55. But the one that we actually need is the absolute value. Alright, so that's the one with the stroke. That's the one with the stroke. So what it just means is 6.45 here, 3.45 here, 0.45 here, 2.55, 5.55. Okay, and when we're done, we now move to the final one, f multiplied by x minus bar x. Okay, f multiplied by the absolute values. So we have 32.25, 5 times 6.55, 32.25, then followed by 62.10, 62.10, 18.90. Just keep multiplying this column. 5 times this, 18 times this will give you that, 42 times this, 27 times this. So 2.55, 68. Okay, 68.85. Then 8 times this, so 44.40. So yeah, we're done. So when we are done with that, we have 226.5. 226.5. So with that, we can get our mean deviation. Our mean deviation is going to be 226.5 divided by 100. That's going to give us 2.265. Right? So starts 2.265 as far as they're concerned is approximately 2.26. Right, so just if we look at this one, this class boundary and whatever that we do, okay, it's not here. This guy, what is it? Anyways, let's do it. So next thing is to solve question B, which is determine the percentage of students' height that fall within the mean plus, first one is 1 mean deviation, second one is the mean plus 2 mean deviation, then all of that. So let's just note our mean deviation. Our mean deviation is 2.26. 2.26 into decimal places. All right. So yeah. So bi by x plus or minus 1 mean deviation is just mean is 67.45. So just saying 67.45 plus or minus 2.26. Now 67.45 minus 2.26, that one's going to give us 65.19. So 65.19 to 69.71. 69.71. So we are trying to look for students that literally fall within this range. The percentage of students that fall within 60, is this student now? This is the percentage of students height that fall within 65.19 and 69.71. All right, so what we now have to do is that we need the class boundary, right? We need the class boundary. So I could, since we are done with all of these parts, our CB 59.5 to 62.5, 62.5 to 65.5, 65.5 to 68.5, then 68.5 to 71.5, 71.5 to 74.5. So where are we going to find 65.19 in this boundary? 65.19 in this boundary. So the first place where we are going to say is here. So it is a part of this. Now, those that are, because here, this particular boundary, you have those within 62.5, whatever it is that they are measuring the height in, maybe in inches or maybe in meters or whatever. Let's even say it is in meters. I don't know, maybe height of students is meant to be in meters. Whatever the unit is, right? So you have, let's say inches. So you have 62.5. Okay, let's just have some 62.5 inches, right? 65.5 inches is number of students there are 18. But 65.19, it's not everybody that is here that belongs to 65.19 is not talking about all of you that are here. It's just a part of it. So what we now have to do is we need to get what we call proportion. So proportion of these students in this interval that fall in this boundary. So how do we calculate proportion? So proportion is going to be equal to this upper boundary here, 65.5 minus these students, because we are just looking at students within 65.19 to 65.5 in this boundary. So minus 65.19, then divided by the class size. What was the class size? 60 to 62, that's 3. That's 3. So equal to 65 points, that's 0.31. 0.31 divided by 3. So 0.31 divided by 3 is going to give us 0.1033. So the proportion of students that are of this height among this entire boundary, right, is just 0.1033 of the total frequency. So if you now get the number of students, right, that's from 65.19 to, because when we are still going to 69.71, so you are still actually still coming down. Do you understand? Don't worry, you are going to get little by little. So the number of students will then be equal to the proportion of students times frequency of students, of students' height, proportion of students' height, frequency of student height. So this is going to be 0.1033 multiplied by, we are looking at this, so this is 18, frequency is 18, and then that's going to give us um what exactly, 1.86, approximately 1.86. Yeah, that's that. I think you can just erase the question. We're done with this part, but we are going to 69.71. So look, we'll come down. This is 65.5 to 68.5. So that means, since we've not exhausted 69.71, we've not got 69.71, that means all these students too will be part of our range, the range that we're looking for. The reason why we just used, the reason why we did proportion here was because there are some students that are not up to the beginning of our own interval, right, based on mean plus or minus the deviation. So some of them are not here. So it's only a part of them that are there. That's why we have to look for proportion. But if you come here, 65.5 to 68.5, both of them are still within 65.19 to 69.71. So which means all the students here, where is it? All the students here, right, also fall within this range. So we have 1.86 students, right? Then we're also going to have all the students within 65.5 to 68.5 are part of our interval, are part of 65.19 to 69.71 interval. So what are those students? So number of students so equals 42. So 42, yeah. But are we done? We are going to 69.71. So this is 65.6. So 69.71 is still around here between this and this, but it is not everything. So we need to do proportion again. So our students, where we are getting to, is from 68.5 to 69.71, but doesn't get to this part. So let's calculate proportion of students again. So proportion of students within 68.5 to 71.5. So it's our upper interval. I don't know if that is the language to use, that we are not going to use to subtract. And look at, when we started, it was the upper class boundary of this interval that we used to subtract our own opening class boundary. But here, because it is ending here now, so it's not going to be 74.5 minus, it's not going to be 74.5 anyways. So it's going to be where our interval is ending minus this opening interval, minus this one. So that's just the end of the road, for us. So we're looking at right, I want 69.71 minus 68.5. All right, divided by the same way, divided by the class mark. So when you do this, you are going to get 0.4033. So equals 0.4033. Is that the end? So remember that we've gotten number of students that we've gotten 1.86, we've gotten 1.86, we've gotten 42 students. So that's equal to the total number of students. So we then erase, I want to erase. So the number of students in this interval that falls within our own interval, so number of students will then be equal to the proportion of those students, 0.4033, multiplied by the frequency, that is we're here, multiplied by 27. 0.4033 multiplied by 27 of them, that's going to be 10.89. 10.89. So our total number of students, so we are done because we've exhausted the interval at the interval of this. So our total number of students is now going to be, total number of students, total of student height within bar x plus 1 main deviation is then going to be equal to 1.86 plus 42 plus 10.89. When you are done, you get a 54.75. But what the question asked us to calculate was the percentage of students that falls within this interval. So how do we get that? To get the percentage, so the number of students that falls within the interval over the total number of students height. Okay. So what we are basically doing, so the percentage is going to be the number of heights within mean plus 1 mean deviation over sum of frequency then times 100, because that's what the question says we calculate. So number of heights is we have 54.75 divided by 100 times 100, which is equal to 54.75%. So the reason I'm writing this formula is that so that you don't think it's always over 100. It is over 100 here because the sum of frequency is 100. So you could do a different question where the sum of frequency is not 100. So whatever you've gotten divided by that sum of frequency multiplied by 100 is going to be the percentage of whatever you're looking for that falls within a particular um, interval. Okay, maybe you are using it could be the same for standard deviation too. So maybe you are using the mean plus or minus 1 standard deviation, the mean plus or minus 1 mean deviation. Like this is just how you go, about it. So again, for you to understand it very, very well, look at the second one. The second question, for instance, is let me see if I can. Okay, I don't want to remember that. It says, second question says, you do the same thing for bar x plus or minus 2 mean deviation. So what you are doing is 64.75 plus or minus 2 times the mean deviation of 2.26. So when you do that, that's going to be like a 5.52. So 64.75 minus 5.52. So that's going to give you 62.93. 62.93 to 64.75 plus 5.52. And this paper has 71.97. 71.97. So this is going to be the new interval that I'm going to be working with. So how do you go about it again? 62.93, because we are going to do that as an assignment. The one for mean plus or minus 2 mean deviation, the one for mean plus or minus 3 mean deviation. That needs to be your assignment. So after you've gotten this, you will have to look at the class boundary again. Your lower limit is 62.93, upper limit is 1.97. So where will you find 62.93? This is 62.5, so definitely it's not even here. I'm not getting to this part. So 62.93, we started from here. And because 62.93 is going to be within. So it's between 62.5 to 65.5. So you have to get it proportional because not everybody here will fall under 62.93. 62.5 is not there. 62.51 is not there. 62.6 is not there. Do you understand? So you are going to find the proportion of 65.5, which is the upper class boundary, minus 62.93 divided by the class mark. That will give you the proportion. And that proportion you multiply it by the frequency. That will give you the number of students that are of 62.93 height and above. Right? So I'm like, it's like you're coming from 62. Oh no, where is this? Like you're coming from 62.93, which is after this person, and you keep driving until you get 71.97. 71.97 is around here. And so all these ones that you jump, the total number is going to be inside of your calculations because from this interval, 65.5 is within this interval. This to this is within this. So all the students for two, you add it. 68.5, 71.5 is within this interval. So all the students say you had it. But here you have to do a proportion. Because what you have is 71.97, but the highest is 74.5. So they don't get your own interval is not up to 74.5. Right? So you are going to do 71.97 minus 71.5 divided by what? The class interval multiplied by the frequency to get the number of those heights among these 8 numbers, okay, that is within this particular interval from this class boundary. So when you do that, add everything up, find the proportion, and then you're good. You do the same thing for the mean plus or minus the plus or minus 3 mean deviation, and then you get your answer. So it will not be very simple to get at the beginning, but then when you take your time, consider it's a very easy thing to understand. So yeah, thank you. Next class we're looking at concept of standard deviation and some pretty new things about it. Not new exactly, but some things that you should know about standard deviation which you may not know um, at this point. Thank you very much once again, everyone. See you when I see you. Have fun.